4 is about equilateral triangles. However, we've already kind of learned about this. So the focus on topic number 4 is how can I take what I know about equilateral triangles and apply it to certain types of problems. So we already know that equilateral triangles have 3 congruent sides, you've seen in the tick marks here, right? And 3 congruent angles, which is why all 3 of those angles are labeled x. They're all the same thing. And so this first example is just kind of like an intro. It says calculate the measure of the angles in an equilateral triangle. So I want to solve for the angles, and I want to do so by solving for x. Now whenever I have to solve for x, I have to set up an equation, right? So looking at these 3 equations here, I know that all 3 of these angles are going to be congruent, but I can't set x equal to x. That doesn't help me at all. It doesn't help me figure out what the x value is. I want to set expressions that are different equal to each other. But we do know something else about 3 angles in a triangle. We know all 3 angles in a triangle add up to 180 degrees. So I can say x plus x plus x is going to equal 180 if I added up those 3 angles. We'll combine like terms here. X plus x plus x is 3x. That's going to equal 180. Now solve, divide by 3, and we get x equals 60. Okay? So that means since x equals 60, all 3 of these angles are 60, which we did, I believe, during the last, during our topic number 2 notes, right? We figured out, oh, all the angles have to add up to 180. They're all congruent, so we did 180 divided by 3, and it's the same thing, okay? So now we just proved that the angles are 60. Let's actually solve a problem involving equilateral triangles now, all right? So looking at the example, we know that triangle XYZ is an equilateral triangle. It has told us that. Immediately, what I want you to do when you see the word equilateral, you're going to mark the sides and their angles. So I'm going to mark and say all my sides are equal. Boom, boom, boom. And I'm going to mark my angles. I'm not going to mark them as all congruent. I know what their measures are now. I'm going to mark them all as 60 degrees. If you do this first, the rest of your questions will become much easier whenever you see an equilateral triangle. Tick mark, tick mark, tick mark, 60, 60, 60. Okay? Let's look at question B now. Question B asks us to write an equation and solve for x. So if I'm writing an equation, I don't have my angles. I don't have an expression to help me there, but I do have an expression for my sides. And what do I know? Those tick marks mean that these sides are congruent, so I can set those 2 expressions equal. X squared plus 15x has to equal 11x plus 12. Okay? Right away, you should be thinking in your head, this is a little bit weird. We haven't done this for a while. This x squared right here, that's a quadratic. That means in order to solve this problem, I'm going to have to factor. So a big reason why we're going through this problem right now is to review the factoring skills that we haven't done that we didn't do in Unit 2. Okay? So when I factor, I can't just start by looking at this equation here. I have to set it equal to 0 first. So that means I'm going to take all of this stuff and get it to my other side, okay? Well, how do I do that? If I want to move the 11x from the right to the left, I'm going to subtract it. I'm going to subtract 11x from both sides. And what do I get here? I get x squared. Notice I can combine these two. They are like terms. 15x minus 11x is 4x. This cancels out. I'm going to bring down my equal sign, and I'm left with 12. And I'm going to ask myself, is it set equal to 0 yet? No. I have to move the 12 to the other side. How do I do that? I subtract 12 from both sides. I get x squared. I can't combine these. These are no longer like terms, so I'm just going to write plus 4x minus 12, and that's, bring down my equal sign, that's going to equal 0. Now I'm ready to factor, okay? When I factor, how do I fill out my box here? The first term, x squared, goes in the first box. The last term, negative 12, goes in the last box. And I think about my 2 numbers. So I'm thinking about 2 numbers that are going to multiply to that last term, 12. If I had an a value, I would have multiplied it, right? 1 times negative 12 and then they're going to add to the middle term, 4. So I'm going to do some investigating and think, all right, what are my factors that multiply to 12 and add to 4? I think if we use 6 and 2, 6 times 2 is 12, okay? But notice we're multiplying to a negative, so one of these factors has to be negative. I'm going to use this second equation here to figure that out. If I do negative 6 and a positive 2, that would get me to a negative 4, and that is not what I wanted, okay? So instead, I'm going to have a positive 6 and a negative 2. 6 minus 2, or 6 plus a negative 2, that does get me 4. So that means that it was 6x and 2x. Those were my mystery numbers, right? And I can use that now to fill out the outside. So the outside of my box, I have x times x. Let's use a different color here. X times x, right? X times what is negative 2x? Well, that's a negative 2. X times what is a positive 6x? That's a positive 6. So my factors then are x plus 6 times x minus 2. And remember, this still equals 0. So from there, how do I actually solve for x? I solve for x by recognizing, well, if I have a product, I have something times something, and it equals 0, I know that that meant that either this first factor had to be 0 or this second factor had to be 0. And then I can solve from here, and I can subtract 6 from both sides and add 2 to both sides, and we get that x equaled 6 or x equaled 2. Oh, excuse me, I was wrong. Sorry. X had to equal negative 6. 0 minus 6 is a negative 6, or x equals a positive 2. And now we're correct. But, oh crap, I got 2 x values here. Which one am I going to use? Can I use one of them? Can I use both of them? Right? And you got to figure that out. Okay? Let's look at the other questions, and maybe that will help us. Our goal is to, in C, is to find the perimeter of triangle XYZ. In order to find the perimeter, that means I have to add all 3 side lengths, which means I need to find the side lengths. So let's plug in here. Okay? We're going to evaluate. Let's use negative 6 first. I'm going to evaluate into this expression, 11x minus 12. When I do 11 and I plug in a negative 6, and then I add 12, 11 times negative 6, that's a negative 66. And then I'm adding 12 here, that gets me a negative 54. And I'm going to think about this in the context of the problem. Can a side length measure negative 54? I don't think, you can't like walk negative 54 feet, right? Negative and lengths don't make sense for us in this class in geometry. So this is wrong. This does not work. Okay, I'm going to do a big X out of that, right? Which means that the X value of negative 6 didn't work either, and I'm going to go over and cross that out, okay? That means the X value that I want to use is 2. So let's plug in X equals 2. 11 times 2 plus 12. 11 times 2 is 22. 22 plus 12 is 34. 34 makes a lot more sense to me for a side length, a positive 34. Now remember, we need all 3 side lengths to find the perimeter. So it's an equilateral triangle. If one side is 34, well, all the sides are equal. That means all the sides are 34. And to find the perimeter, I can do 34 times 3, or you could do 34 plus 34 plus 34. And I believe that all added together is 102. So there is my perimeter. Okay? All right, we only have one more question. The last question, what is the measure of angle Z? Well, I want to look at the angle Z here, and look at that. Because in the beginning, I marked my 3 sides congruent and my 3 angles as 60, I'm already done with this question. What is the measure of angle C? We already know that it's 60, okay? So what's very important is that you come back to these notes if you are having trouble with factoring to go through that type of problem again. And you can head on to the next video or to the class and learn about isosceles triangles. All right, have a good night.